Well, welcome to this interview about data science and artificial intelligence. I have Katja and Prayson with me today. I'll have them introduce themselves. My name is Nicholai Stålung, and I'm the lead data scientist at Trifork. Trifork is a software consultancy company where we try to bridge the gap of needs and technology. So I'm really excited you guys are here. I think we can have a nice discussion. I'm looking forward to your stories. And please, Katja, can you introduce yourself?
Sure. Hi, I'm a data scientist at NVIDIA. I work in Germany, in Munich, and my background is in deep learning and computer vision. And in my day-to-day work, I help customers in developing and deploying efficient AI models for video analytics. Thank you for having me today.
Well, I'm Prayson, Daniel, and I'm a principal data scientist at Entity Data Business Solution here in Copenhagen, or the Nordics. Well, my day-to-day is causing trouble in ML world, but basically we just help our clients build ethical and trustworthy algorithms that they can put in production in clear conscience. And I said I'm causing trouble is, as you know, I am always trying to challenge some norms thrown into GDPR and Altai and all those things. Yeah. Yeah,
and you just had a talk on black box models and if we should even look into them. Maybe you could elaborate on your talk just for.
Yeah. So I think we are. Most of the time we are living in a kind of, I'm usually scared to say an illusion, but let me just use that even though it's a heavy word, but that whenever we can explain our model or whenever we can interpret it, therefore it is X. They go like it is trustworthy or it is, and my case is like not really. We can have a model that is completely transparent, very interpretable, but extremely biased. But then in the other flip of coin, we can have a completely uninterpretable model, God forbid, a completely black, but yet very ethical. So my case is what stopped me from using one over the other. And maybe the trustability, accountability of the model has nothing to do with the modeling themselves, the mechanism, but the entire space behind. So my talk was going beyond the interpretability and explainability of model and coming with a way to which we can fulfill all these needs of fairness, etc., without having to unveil the models themselves.
So what is your take, if for the layman? What is your take? How do you attack this task?
Yeah. So I usually love telling stories and coming with the explainable images. So my best images was with this container where we fill water in this container and we start making holes. And we assume the container is transparently, almost like glassy. So we know if we make a hole here, the pressure will fall sudden like this, and we put the hole a bit down, then the pressure is a bit longer. Then we can say the water is here. And when we don't see water coming out here, we can say it has passed that level. But then it says, what happened when we black paint this container completely black and we repeat the same experiment of putting holes? Apparently we can still explain about the pressure and know whether the water has passed this without seeing where the water is. So in this case we come with something called counterfactual explanation, to which you just need to perform test of your model. So by saying, if I put these features, what do I get back? And if I can give different counterfactual and get the same result, then I can come with good explanation. For example, my model is not affected by gender. So I can take in and change only the gender parameter to male, female, and see do I get the same predictions, right? My model is not affected by ethnicity, so I will pass a Christian, a Jew, a Muslim, and do we get the same results? And if I pass those, then I don't need to unveil my model to tell you that it fulfill the guidelines we are trying to pass.
So Katja, how does NVIDIA tackle this, or how do you tackle the whole area of explainability and interpretability?
So as I work more on practical side, of course NVIDIA does some research in explainability and interpretability, but for my particular customers and clients, the general outcome of the model is most important. So how can you apply? How does your model perform on like test sets? How does the model perform? The most important, how does the model perform in the real setting? Like there is often a case when our customer or partner has trained a model for like some other customer of them, and they said, hey, the model works well in the laboratory scenario, but then we put this model in the real life and it doesn't work and doesn't detect anything or it doesn't segment anything. So we usually help our customers and partners to solve these problems. And the best way I think is just still testing your models. Of course, there are like algorithms like GraphCam where you can visualize the attentions, but it is really questionable, like if the model like visualizes the things which will lead to final outcomes. So I kind of also agree with you, and I'm the same position that it's probably not really necessary to look inside, but you really need to take care of what is coming outside of your model.
Yeah, that's very interesting, and we all agree to that fact. You both are advocating a testing regime for models outside of the lab, which I'm also a heavy advocate for, because that's the only way we know how these models will perform. In our world, we're dealing with variance, as opposed to normal computer scientists. That means we cannot just deal with Boolean value and say it's passed or not passed. It can be any value in between those, right? So, my next question for you, because you're working with primarily video and image analytics. So maybe you could explain. So what does that entail, and what parts of that pipeline of deploying models are you involved with?
I'm actually involved in the whole end-to-end process. I usually start early with training the model and, if it's applicable, then curating the data set, checking if the data set is good enough, if all classes are well represented in the data set. Then the next important step is training the model efficiently. So it's very important to iterate fast, to try different hyperparameters, and training also needs to be done in the most efficient way. So utilizing multiple GPUs if possible, utilizing automated mixed precision. Many people don't know that this technique exists, and they still do run their long trainings even if they have supported GPUs.
Well, maybe you can elaborate on mixed precision, because that's something new, right, for a lot of data scientists. Yeah. How does that work?
Well, it's a hardware associated feature. So in the newest generations of NVIDIA GPUs, we have this feature which can enable training in mixed precision. So you have your data in floating point 32 precision, it enters the model, but then when you run through the convolutions, you do it in floating point 16. To preserve the accuracy, you switch back to floating point 32 before calculating the loss and doing the optimization step. And then again, you switch back to floating point 16 and you back propagate in floating point 16. By doing that, you can run your training faster, you can train bigger models, and you can train bigger batches. So there is a big advantage of that, and it's usually no more than a couple of lines of code in popular frameworks like TensorFlow or PyTorch. Or if you're using our Java toolkit, it's just basically a single parameter which you pass to the command line. So it's a super, super nice feature, and many people just don't know about that. But it's really important to iterate more often and faster when you tune your hyperparameters, right? And then after the training, of course, there is deployment. And I also advise our customers how to deploy your models in the most efficient way using our frameworks. So,
yeah. Well, mixed precision is something I found useful just a few days ago. So that was an eye opener in the training time on the GPUs that we use. But Prayson, can you maybe just like talk about your preferences within data science and what piques your interest?
Yeah. So I think after not being long, but after going through different journeys in data scientist, I've come to a conclusion that they are kind of different paradigm as a data scientist. So the first time when I receive a task, in the younger me, I will just jump in. XGB boost is the first algorithm you go to, and
like all of us,
like every one of us, right? But then I discover that most of the time, as you mature, you start asking, maybe sometimes the best model is no model. And people go like, what? And I says, okay, the best deep learning is no deep learning. And says, what? No, we do love that. But I discover that in most cases, we need to start with the basic questions, right? Is a statistical table going to solve your problem? And if it does, then probably we shouldn't go. So you're not doing images classification. So maybe it's just a simple linear model or logistical model that will do the job. So no need to pull the guns out. And then there's a time when we need to pull the guns out, right? So we need to go deeper. And my area is mostly coming to transformers, natural language processing. We do image, but not at that scale. So we do very basic image segmentation, tracking and measuring of animals' weight and height just by images. But then the deepest part we've been working on is natural language processing, and there is where there's a huge attention at the moment. And all this cool stuff we're borrowing from computer vision. So thanks to them, we are applying the computer vision ideas in natural language processing, and we hope maybe some of our ideas are going back, which I see they're starting to use attention mechanism also in a computer vision.
True.
So it's like a back and forth helping different field works together. What excites me most when it comes to all the AI field at the moment, of course maybe later I change, is the whole entire ethics and how we make sure that we have an end-to-end pipelines that ensure us. So from the moment we acquire data, from the moment we agree what we're going to do, to the deployment and the continuous monitoring of our models. So how do we create a pipeline that is traceable, visible, and we can explain to different stakeholders. We can hold each part in this puzzle accountable, from the person who sent the data to the person who received the data, from the person who made sure that our data was not mislabeled. Because I just discovered nowadays you can do a task like computer vision and try to beat what you call the standard out there. But then you look at the standard, their data set is completely corrupt in some of these things. So they say this is a sheep, but when you look at the sheep, you go like, no, this is a car.
Yeah, I read somewhere that 40% of the COCO data set is actually mislabeled.
So the idea behind is like, oh, so sometimes we are actually optimizing to things that we need to go back and so it says, okay, we need to check our data sets. We need to maybe relabel them again. And there's good technique to find those things very nowadays, right? But again, I'm excited about the ethics. I'm excited about the classical data mining, the part where we can just look at the data and see association and create almost the old school if else do something, right? And then from there, when that is not enough, then we go to the next level and then to the next level. So that's what excites me at the moment.
So how did that become your field of interest? Like, did you have any bad experience, or was it more like this is something that's not covered by people, or is it people are actually talking about it but they don't really know what they're talking about? So it has to bite back, and it bites back when you receive a legacy code. So somebody has built this wonderful architecture and deep learning, and they have done all these things, and now they're gone. Because data scientists have this 2.5 years lifetime. If you
what do you mean by that?
go look at the profile. Yes. 2.5 years, they're away to another company, to another company. I'm also a victim to that. I've done that, but hopefully I am staying where I am.
Are you a victim of that as well?
I can attest.
So we usually say 2.5 years, but then you receive someone else's legacy code, and you go like, oh heaven, how do I proceed? And they just want, oh, we would like to add you just this extra feature. And you go like, oh, it's not just extra. I don't even know how to deal with this. And in most cases, when we receive a legacy code, you usually have two options. You usually say, one, you quit your job because nobody wants to maintain them. Or two, you toss it out and then you start from scratch. Or the best one is you take one component out and put another. And you cross-finger. The person before you had a good documentation, had a good all this. But then I discover if you go simple and you have this in your Git commit, one could always check out back and build from that part where it was still breathable. And this is where I go like start with very simple changes and then build on top and commit all this change. So in this case, I usually have in our commit, I use a lot of tags. So tag them like the baseline and then tag them before deep learning, right? So I can check out before deep learning and build maybe another deep learning model on top of that. But all this part are really important. So that experience is what made me go like, okay, always go simple.
Yeah, that's an interesting idea, branching out early so you can attach multiple models to your workflow, right? So how do you go about that in NVIDIA? Because I know both of you are working to simplify the workflow for data scientists, even though you're working with different fields. So how is that top of mind at NVIDIA?
Well, NVIDIA's position is also like to simplify life of data scientists and engineers, and we try to encapsulate everything which is possible. And a good example is our Tower framework. So we hit the whole engineering part behind this executable. So you basically, to train your model, you just run a simple command on a command line. So basically a person who is using that doesn't even necessarily have to know deep learning. So they need to know how to prepare a data set and what to expect from this model. But then the rest is hidden. And we are working now also on a UI for that. So soon, hopefully next year, we'll introduce a UI for that to make it even more simpler for data scientists, which do not necessarily have to be computer scientists, right?
So how did you end up in a job where you're simplifying stuff for other data scientists?
Well, it's I'm not only simplifying, I also write code, and I have like a lot of experience. I have my PhD in computer science, so
you have the knowledge that everyone else wants, right? So you're the perfect person to ask.
So my initial idea, and the goal is to perfect automation and also simplification of things. And as a person who can develop these tools, I work on that. But I don't expect everybody to know these tools, right? I don't expect every person to know how to code. And in that, I really want to help people just to bridge this gap.
Yeah, just to add on top of that, because what we've been pushing so forward mostly for data scientists is the software engineering part. Because most of us, data scientists, came in the background of notebooks, right? World of very messy code, and luckily I was in a company where we had this inter-team shuffling to remove silos. So I found myself in the software engineering team because they had to package our models and there's where I was introduced to design principles. Whoa, solid. Whoa, what? So encapsulation, dependency, invasion, and go like, whoa, this is it's dessert. So when I came back to our team, and I go like, oh guys, we have to do solid, like encapsulation. So always abstract and all this, and then go like, oh, it's too much code. Yes, too much code, but it's unchanging code. Like I only have to change this, the rest remain the same. So all this part of making things simpler actually comes also for the way we build our softwares, right? The way we do software design. If you can get that good, then it's easy to automate it because it follows certain guidelines. So when I go to you and ask, what have you done? You can say, well, I have used a pattern strategy, or I have used factory strategy. Then everybody knows, factory, okay, so this is how things work. And in that case, people can embed them in UI or executable. But also, for me, what I usually want is that I don't want people to be scared to make a change on a code base, right? So whether you're very skilled or not, we just introduce to testing first. Everybody has to go to that when you join my team. Test, test, test. And then after we introduce you to test, we will introduce you to the basic solid design principle. So you know, okay, if you come to our code, you will have the abstract classes out there, you have the implementer here, and everything is here. And then you're cool, and then it says, change this as much as you like, right? And because we enforce some of those principles through abstraction, then we usually are in a safe ground, mostly.
So I know both of you are very good coders, but you're also working to simplify, like we've spoken about. But is coding part of the future data scientist? Because you're both young, and you will influence how the data science community will be in the next many years. Is that the future of a data scientist?
Well, it depends. I think it's like in every major, you pick your own path. If you don't feel comfortable about coding, you don't have to. There are tools for you. But if you want to create something new, well, of course you need to code. And as you were also like talking about this design patterns, and I think it's like in general can be characterized as reusability. So reusability of code is like the most important thing. And when creating code needs to think of that, to have it in mind as the most important thing. Yeah.
What's your take?
The future is still coding. Why do I say that? I think there's a difference between what we call the citizen data scientist and then a data scientist. So they're usually like a class of saying a data scientist who wants to do something. I want to train my model and do something. I'm not going to develop a new model. I really even don't care about building another optimizer. I don't care about that. So in that level, you really don't need to learn much. There are so many tools out there to do auto ML. But at the same time, I say the future is still code, because code gives you freedom to invent new things, freedom to augment, freedom to think outside the box, right? And I know it gives you this godlike complex where you think things into being, right? It was not there and now it's there. Like you start with a blank, maybe it's .py to do your Python, or .cpp to do your C++, the only language that I know, to do all these kind of things. But for me, I think the future is still code, and the no-code world has been here since when? 1996. Oh, this is the end of coding, and they're still coding. And then they create this GUI where you can put some blocks, but they're still coding because somehow, because we're still inventing new things, coding is still going to be, it's here to stay. And the best thing is, we should just train data scientists and non-data scientists to code in the right way. And this is taking all the principle from the software design.
I have a bit controversial take on that.
Yeah. Okay.
So, well, as a data scientist, my dream is to develop algorithms which will, maybe I will not do that, but somebody will do that hopefully someday, to develop some kind of general AI and imagine of code which writes code. So I think this is the general target and what we are aiming at. But I guess there will be years until it will be possible.
That sounds interesting, right? So, well, the last question I have is on top of that. So what will you be working on tomorrow? What's your interest tomorrow as opposed to today?
Well, I'm still very interested in images and image processing, but I think it all is coming that we all process different sorts of sorts of data and images coming together with text. So I'm looking into like mixed deep learning models to get together all the insights from the world in one big insight.
Wow, that sounds like a big task. Yes. Good luck with that. And you,
Thank
Prayson,
you.
what will you be working on tomorrow?
Well, I'm working on raising an army of data scientists who are good software developers and also good at performing ethical tests, not just software developers, that means they can perform software tests, all the unit tests, integration tests, but also this ethical element part. So not raising an army, but just inspiring the new data scientists who are really in love with software engineering, and that's part we are missing, right? So we just need to have this reusable code, and we are starting to see that, like the Hugging Face with all the natural languages, that they don't really care how you build your model. We can always package it and everybody can use it in the same way. So they are this new path of building beautiful reusable packages. And so for me, I'm just adding more element of fairness test and all these other things that needs to be as a whole. But where am I tomorrow? I'm just trying to bridge the gap between data scientists, stakeholders, and software engineer into this one space.
Sounds interesting.
Yeah.
Yeah, I hope you'll raise your army and you'll get your model. I really appreciate you taking the time to answer a few questions. It's been lovely, I could say. Very interesting to peek into your heads.
Yeah.
So thank you very much.
Thank you for having
Thank
us.
you. Yeah.